20th, guys. Look at this. The date now starts with Christmas dates. Look at this. 12th month, 20 what? Something. Today's 12/20. Yeah, I mean, I can't believe it. So yeah, what you're doing today is you are learning. I thought today would be a perfect day to fit this in. You are learning to interpret, you know what that means, like make sense of, interpret, and write functions. So I will not take this for granted. If it seems like I'm being a little more deliberate, then just know that it's based off the experience from a couple of hours ago. So the idea today is we're going to take word problems and we're going to write them as math problems. So in math, we call that modeling. So when you take like a word problem, something like a paragraph or a story problem, and you make it look like a math problem, there's a name for that. It's called mathematical modeling. So we're going to take situations and we're going to write functions that represent those situations. And then we're going to answer some questions about the functions, okay? So for this part of the lesson, I went from 4 examples down to 3, and now I'm back up to 5. So the first one will take the longest just kind of as we go through it. And then the others, I'm just trying to get you prepped up for the assignment here. So here's how this is going to go. And the problems on Delta are going to be longer. Like they're going to have more words. I'm just going to try to cut a lot of the words out and get right to the meat and potatoes of it. So let's say you get a job offer. And, you know, I know you guys are used to as teenagers, you get jobs and they're like $12 an hour or 14 per hour or something like that. When you get older, you're going to get jobs that have salaries, like annual salaries. And so, you know, so let's say you get this job and they call you and say, hey, we'd like to hire you. And in the contract, they offer you $40,000 per year. But they also say in the contract, which is a pretty smoking deal, that they're going to give you a $3,000 per year raise. So, you know, provided that your reviews are good and that your productivity is high, you show up to work, you're not late, you know, stuff like that. So what we're going to do is we're going to turn this into a mathematical function. We're going to model this situation using a function. So let's get this out of the way. Because it's involving salary, if this were like a test question and I could write whatever I wanted, I might name my function like S of Y. And I warned you about this. Remember yesterday they were all F of X, G of X, H of X, stuff like that. But let's think about this. What would S stand for in this function?
Salary.
And what is Y?
Year.
Good job. So in a case like this, we say that my salary is a function of the number of years for which I've worked, right? So like if I've worked for 1 year, my salary is affected by that, correct? So we're going to take the information on the television up there and we're going to write a function. So our function, and by the way, you don't get to name them today. Delta Math will name them. I think it just picks random letters, like it's weird. But if I were doing this on a test, that's what I would call mine because I like my letters to kind of match the context. So my function S of Y looks like this. Let's think about it. Common sense. The part of my salary that's guaranteed, that is unaffected by time, is 40,000. Bless you. We agree, right? The 40,000 portion of my contract doesn't care how long I've been there. It's like I'm getting 40 grand a year, but I have to add to that a variable value. What would be the last part of this function?
3,000.
3,000 times Y, right? So this is a very Y equals MX plus B sort of situation here where you think about it and the 40,000 actually feels like a Y-intercept. A Y-intercept should always have felt to you like a starting point of a problem, right? And when I get hired on at this company, my starting point is 40 grand. And then I go up at a rate of 30,000 per year. That's my slope, right? So what we just did is we wrote a function that is representative of this situation. Clear? All right, so let's talk about these things. This variable that I'm circling right here has a name. And I was amazed first hour, like how many people were like, yeah, we've heard this before. Like we've talked about this before. This is called an independent variable. What that means is that like it can independently do whatever it wants. I could put whatever I want. I'm independent. I'm free to put whatever I want in place of y just for the sake of a math problem, right? This variable over here, what do you think it is? Good. It's the dependent variable. And the reason we say that is because its value depends on the other one. Like how much money I make at this job is dependent upon how many years I've worked there. We agree. So you're going to be asked this in every single problem today. There's going to be those little drop down boxes when you have to know which one is independent and which one is dependent. So the one that's kind of driving the ship, the one that's running the problem is independent. And then the like final answer, things like how many candies are left in the box, how much fuel is left in the tank, stuff like that. Those kind of final answery feeling things, those are dependent variables. They depend on the other. Got it? And finally, you'll be asked to evaluate functions and then interpret what it means. And so let's say in this particular model, I had asked you to help me find like S of 6. So first off, the math should be simple. The math doesn't change from yesterday. Yesterday, we learned how to evaluate a function. And that just simply means just change the dang letter into a number, right? So where I have my green circle up here, remember, that's my input, independent input, independent input. So if I want to know S of 6, I just put 6 right there in place of Y. And, you know, I'll show work this time, but you probably don't need to see a whole lot of it. It would be 40,000 plus 3,000 times 6, right? Same as yesterday. Evaluating a function doesn't change just because yesterday's over. Like the math is the same. So now what is 3,000 times 6? And then add that to your base salary. What do you get? Very good. So we can say that S of 6 equals 58,000. And I'm not putting dollar signs on these, and that's probably a bad example to set, but you're not going to need to worry about that today either. They're just numerical answers. Finally, when you get to delta, it's going to have some more drop-down boxes, and it's going to ask you questions, and it'll say something like this. Okay, here's what this means. It means that my salary, like after 6 years of employment, would be $58,000, right? Or if it said it backwards, you could say my salary is $58,000 after I've worked there for 6 years. These are really just the kinds of problems where you have to read and don't think that, okay, I did one, I can do them all, like they're all the same. You just have to read. If you struggle with reading comprehension, you won't enjoy this at all. Every problem just is drop down boxes. Just pick the ones that make sense. You okay over there, fruit snacks? Are you sure? You're not sure.
Because you're getting
That's not your total after 6 years. This is how much you'll make every year after 6 years. Every year you make $40,000 plus 3,000 times the number that you've been there. Is that what you're asking? Were you thinking like I've made 58,000 in 6 years? No, if you wanted to know how much, you'd have to sum them all together, like 40,000 plus 43,000 plus 46,000 plus 49,000, and it would be a lot more than 58,000. It's not really a bonus. I want to be clear, your annual salary the first year is $40,000. Year two, you get $43,000 per year. It's not a bonus. You will have jobs that give you bonuses. A lot of places offer like holiday bonuses, Christmas bonuses, performance-based bonuses, stuff like that. So, yeah, yeah. So I would say, are there any questions? But let's hash out another couple, and then we'll say, are there any questions? So for the second example, let's say you're driving down the road, and the moment the math problem begins, you have 18 gallons of gas in your car. And I'm just making this up, like this number is relatively arbitrary, but let's say as you drive, like your particular car, your particular speed, your particular style of driving, you use 1.85 gallons of fuel every hour that you drive. So you can picture that situation, right? You got a nice full 18-gallon gas tank, but every hour, if you like stay at a average kind of rate of driving or whatever, every hour on average, you burn 1.85 gallons of gas, right? So what would be a good name for this model or function? G for gas or gallons. So G of what? H. Gallons or gas is a function of hours. I love it. Perfect variables. What would this particular model look like? Again, think starting point and then change. Start, change. What's the starting point?
18
I love that. What's the change?
minus
Oh,
8.
yes. This example made it into the note card today just because I wanted to make sure you're aware that functions can add, they can also, of course, subtract. It wouldn't make sense to have a positive variable value here because it's not like fuel is like multiplying in your tank. That would be amazing, right? It's actually subtracting, going away. So that's a perfect model for this situation. Which of these is the independent variable? I mean, don't read them to me as letters. Read them as like, okay, good. So the number of hours I've driven is the independent variable. What's the dependent variable?
Gallons.
How many gallons of fuel I have left. Okay? You got to be really aware that this does not represent how many gallons of fuel I've used. That G of H represents how many gallons I have left, right? Okay. You really faded on me there. You good? That's okay. You good? Okay. How about this one? Let's say you're rocking down the road and you're going 75 miles an hour. And we want to write a function that relates distance and time. This problem, which you'll see a couple different versions of this in Delta, is this doesn't really have a y-intercept unless you want to call it 0. But this is a very simple, this is a one-term function. It doesn't flow like the others. The others all have like this jumping off point, and then they grow or they shrink. This one just kind of starts going. So this is founded upon this equation, distance equals rate times time. Right? You've seen that before. It's a simple equation that says how far you go is equal to how fast you go times how long you go. So like simple math, if I drive 80 miles an hour for 3 hours, how far do I go? 240 miles, game over, done, right? If Jack's rocking down the road on his way home going 50 miles an hour, it takes him 2 hours. How far do you have to go? 100 miles, right? Rate times time will always give you a distance, correct? So this function is going to be sort of predicated on that idea. So I'm going to say something like D. Sorry about that. My pen kind of clicked out on me there. I'm going to fix that. D of H. That work for you? So the distance that I drive is a function of the number of hours for which I drive. And this is a very simple model to write. What would it be? Say again? I can't hear you because this thing's on. It's just a multiplication. Boom. Done. Is that what you're going for? I really couldn't hear you, but it's off now, so I can hear better. This darn thing. So 75H, that's it. That's the model. That's the entire model in a case like this. What variable would you say is independent? The number of hours that you drive for. That can be whatever you want. Which variable is dependent?
Distance.
The distance that I've driven. Correct. Got it? All right. The last couple, I didn't put these in the lecture earlier, and I regret this. So there's going to be one question that you might get, you might not get, because you know it's the luck of the draw with Delta Math. There's going to be a perimeter of a square problem and an area of a square problem. So if I were you, Colby, I would probably jot this into my notes. And so I'm going to try to draw a picture of a square. Well, hey, that worked out pretty dang good, if I do say so. Hey, what makes a square a square? Why? What?
All 4 sides of the
Yeah, and the right angles are important, but the sides are what are going to get us through this. Squares are parallelograms with 4 right angles and 4 congruent sides. We're interested in this. Let's say the side of this square is x units long. And why am I calling it x?
Because you don't.
Because I don't know what it is. And honestly, I don't care. It could be 2, 1.9, 36.34. I don't care. It's something. But if it's x, what's the length of this side over here?
Mm.
All right. How about this one down here?
X.
All right. How about this one over here?
Oh.
Okay. So let's talk a little bit of basic geometry here. If I wanted to write a function that represents the perimeter of this square, and I want the perimeter to be a function of the length of one of the sides, what do you think would be a good name for that function? P of x, where the perimeter is a function of the side length. Get used to that language. Perimeter is a function of side length, which means perimeter will base itself off of what the length of each side is, right?
Mm-hmm.
And what would be a formula for the perimeter of this square? How do you do perimeter again? You add all the sides together. So in a very long roundabout way, I could actually write my perimeter function. I'm going to use yellow because I'm going to erase this in a second. I could write it as x plus x plus x, but I'm not going to erase this, and I don't think you should keep it either. Because there's a better way to say x plus x plus x plus x. What is it? It is 4 times x, right? So a correct formula for perimeter to me feels like it should just be 4 times x. So for example, let's say the length of one side of the square is 9. What's the perimeter? 36. 9, 9, 9, 9, add them together, multiply by 4, whatever, 36, right? Which variable is independent? Side length, right? And which variable is dependent? Perimeter. Whichever one depends on the other. Think about those words. It's pretty easy to understand. And then the other thing you're going to be asked to do, and then I'll hop over to Delta Math, is the area. And you guys know that area, so like perimeter, if let's say I were building like a square pen for some animals, perimeter is how much fence I need. Area is like how much square footage do I need to cover with seed or whatever, right? So area is a 2-dimensional measurement. Do you guys all know how to find the area of a square? It is. Area of a square is length times width. So in my case, I think a great name for this function would be a of x. Will Delta Math call it that? Probably not. It'll probably be like v of x or some weird thing like that. But there you go. There's the function name for the area of this square. And what is the formula that I would use? It's not 2x.
4.
It is definitely not 4x. Say that again. Yes, it is x times x. Think about that. It's neat when you see the connection. Like, where does the word, like, who thought to call an exponent of 2 squared? And then you're like, it literally is derived from the area of a, look, square. Neat. So when you do x times x, or length times width, x times itself is just written as x squared. Neato, right? Do you have any big questions so far just about what's going on? Okay, so please no Chromebooks still. Just give me a few more minutes. I think that this will pay dividends if you just give me a few more minutes so that when we get to do this by ourselves, we're not going to be like bombarded with questions about how to do this or this. So can you read this? So walk through this with me. And again, please be a part of this. Don't sleep through this and then wonder why you're lost. So here we go. Paisley's buying some bagels. Each bagel is $1.25. Answer the questions below, blah, blah, blah. Okay, so each bagel is simply put $1.25. This is going to be similar to the driving problem where we were going 75 miles an hour, right? Like no bagel store, when you walk in and say, I need some bagels, is going to say, okay, I'm going to charge you $10 just to have the right to buy my bagels, and then it's $1.25 a bagel. Like no one does that, right? So this is one of those simple short functions. So here we go. The independent variable x represents what? Very good. The number of bagels. I can buy as many bagels as I want. That's an independent variable. What's the dependent variable? The price, the total cost of the bagels. Because the what depends on the what? Because the total cost of the bagels depends on how many bagels I bought. Good? Okay. How about this next one? A function relating these variables is what? I got to type in a function. What's it going to be? Again, I can't hear you because you're quiet as it is, but this thing's just going again. I have good ears too. For a guy that's pumped loud music into my ears and played drums for like 40 years, my ears work. I just can't hear you. I just need the name of the function, the math of it. It involves the number 1.25. I have to multiply that by x, don't I? So the function is $1.25 times x. There is no plus or minus, again, because there's no start point. Like you don't walk in and say, here's $5. Do I have the right to place an order now? It's like, no one does that. Hope. So now we're going to do math. The next one says C of 6. So if I want to know C of 6, what do? I put 6 in place of x. Anyone got a calculator? What's $1.25 times 6? It is not $9 in anything, for the record. That's more of what I'm getting. Yeah, the 6 times the whole dollar is $6, and then 6 times a quarter is $1.50, which is $7.50. I agree. Use a calculator if you want, but to me, I think this is coming out 7.5. Meaning what? 6 bagels will cost 7.5. So anyways, like I said earlier today, I did one problem and I thought we're good, and I was wrong. So let's do at least one, maybe two more together. And if you don't know what's going on, just ask, okay? So we're going to send that one. That one felt pretty good, huh? Let's go again. So Jacob bought a bag containing 100 small candies. He starts eating them. He eats 5 candies every minute. Jacob is like me. He's got a sweet tooth. Homie loves his candies. And so here we go. The independent variable in this case, x, will be what? No. I'm not even clicking the drop-down box. I won't do it. You tell me. What is the independent variable?
Per minute.
No, I already know. He eats 5 per minute. That's not a variable. How many minutes he eats candies for? If Jacob eats candies for 1 minute, he's eaten 5. If he eats candies for 2 minutes, he's eaten 10. If he eats candies for 3 minutes, that thing that's varying that I can change, 1 minute, 2 minutes, that's called a variable. Therefore, the independent variable is the number of minutes he spent eating candies. 5, rate, not a variable. We know all that stuff. It's not a variable if you know it. What's the dependent variable? I would want to, at this point, say how many candies he's eaten, but that's not going to be one of my choices. That's not what we're looking for. Here, I'll give you a hint. At no point, that was a good hint, wasn't it? At no point in this problem does it say, I want to know how many candies Jacob has eaten. The question is, how many are left in the bag? So the dependent variable here is how many candies are left. Clear? So the independent was how long he munches on his snacks. The dependent is how many are left in the bag. Now, having said that, because the what depends on the what. What depends on what? The number of candies left in the bag depends on the number of minutes he's been scarfing on his candies. Now let's write a function. This is going to be like the gallons problem or like the salary problem. It's going to have a change in it, isn't it? A plus or a minus. What's the starting point in this problem? Right, so we definitely want to start our model with the number 100. The number of candies in his bag increase or decrease? So I need a minus sign.
-5 and
-5
X.
x. 5 per minute. X is the number of minutes. Perfecto. What is n of 7? So Jacob ate candies for 7 minutes. He's going to have a bellyache. What's 100 minus 5 times 7? What's 100 minus 35? 65 is perfecto. Meaning, after eating candies for 7 minutes, there would be 65 candies left in the bag. Someone who doesn't do what I do for a living would look at this and say, that's a lot of work. And I look at this and say, this is great. This assignment forces you to understand that variables aren't just X's and Y's. They're like things in a problem that change. As one changes, the other changes. That's what math is all about. It's how variables behave, man. Let's go again. One more, okay? You feel good still? You feel like you can do this? Yeah.
I think it's 65.
Because I had 100 candies in the bag and he ate candies for 7 minutes, but he eats 5 per minute, right? So if you put 5 in place of X, 7 in place of X, what is 5 minutes times, God dang it, I did it again. What is 7 minutes times 5 candies? So he's eaten 35 candies, hasn't he? You got to subtract that from 100. Because like I said, the problem was never written to, no one cares how many candies Jacob's eaten. The problem was all written about how many candies are left in the bag. So you have to subtract. How about this one? Damien makes $8 an hour when he babysits. This is not going to be a plus or a minus problem, right?
No.
This is just a straight up single term. So here we go. What's the independent variable in this problem? Very good. Independent is how many hours Damien works. What's dependent?
The amount of minutes.
The amount of minutes. Not per hour. That is not a variable. Sorry for raising my voice, but I'm not sorry. The number of dollars per hour is not a variable. I know how much money he makes an hour. It's $8. So let me ask you again. Parker, choose your words wisely. What is the dependent variable?
The amount of money makes after.
Correct. We know how much he makes. He makes $8 an hour. That's not a variable. That's fixed. What depends on what?
The amount of money he earns depends on the hour.
The amount of money he earns depends on the number of hours spent babysitting. What would my function be in this case?
8.
Simple function, 8x. What's m of 6? 48. Meaning 6 hours of babysitting will get $48. You feeling it?
That sounds easy.
Okay, so this is what happened earlier today too, was everyone was like, yeah, I think we got this. And then it wasn't like that. What do you think? You ready to rock and roll? All right, let's do it. Hit the old daddy delta math. Let's see how you do. Yes, you may.
Oh, yeah, it was small. I don't know.